This video is going to overview some different procedures that are multivariate procedures. So, the last videos covered multiple regression analysis, and in multiple regression your dependent variable is an interval ratio level 1. Logistic regression is the preferred procedure when your dependent variable is dichotomous, that is, when it has two categories. So logistic regression examines the association of predictors to a dichotomous variable. It draws quite a bit on what we've learned about the odds ratio. I'm going to present two formulas for logistic regression. The first one predicts the log of the odds. Now, look at p over 1 minus p. P conveys the proportion that experiences an event. So 1 minus p is the proportion that does not experience an event. So p over 1 minus p is indeed a formula for the odds of an event. Ln stands for the natural logarithm. So this formula predicts the natural logarithm of the odds of a given event. And that is called the logit. It predicts the logit. Now, in this format, interpretation of the coefficients yielded by the logistic regression equation is not intuitive. So we're not going to spend any time on this logistic regression formula. With some arithmetic, the logistic regression reformula can be rewritten in a way that is more intuitive. So here is our rewritten logistic regression formula. And now you can see that the formula predicts not the log of the odds of an event, but it predicts the odds of an event. In this formula, E is the base of the system of natural logarithms. The text has some footnotes to help you interpret logarithms. You don't need to be able to interpret logarithms or E to understand the formula expressed in this way. You'll see how to interpret the formula as we get into an example. So what we are going to do in our example is predict the odds that a responding adoptive parent will respond very positive versus any other response regarding the impact of adoption on the family. So we have a two-category, dichotomous dependent variable, very positive response versus any other response. And we will simply use the same predictors as were used in the multiple regression example in the prior video. Here are our logistic regression results. So let's go ahead and interpret the EB coefficients, that is the exponentiated coefficients. These are the coefficients that presented in the second equation. So the coefficient for education mom is 0.837. Now recall from the prior video, mom's education was measured on a 5-point scale, where 0 conveyed less than high school, all the way up to 4, which conveyed a graduate school. So that as mom's education increases by 1 point on this scale, that is, for every 1 point increase on the scale, the predicted odds of the adoptive parent responding very positive regarding impact decrease by 16.3%. So as education goes up, the odds of a very positive impact are decreasing. And where does this 16.3% come from? Well, what you can do is take 1 and subtract from 1 0.837, that is the coefficient, which yields 0.163, and then multiply times 100. And so we get 16.3% lower. Let's interpret the EB for behavior problems, which is 0.948. Now recall from the prior video that behavior problems is measured on a scale with possible scores from 0 to 236. So for every 1 point increase in behavior problems, the predicted odds of a very positive response decrease by 5.2%. And here is our calculation, which yields the 5.2%. I note that where an EB coefficient is greater than 1, this conveys that an increase in the predictor leads to an increased odds of the event. So for foster parent, the EB coefficient is 1.257. Foster parent is coded with 1 for adoptive parents who were prior foster parent and 0 for others. So this is conveying greater odds of a very positive response where the adoptive parent was a prior foster parent. That is where the predictor is coded as 1 rather than 0. Just presented interpretations in the prior slide are less than intuitive because the measurement units for education mom and behavior problems are unfamiliar to us and basically are unique to this particular study. So to help in interpretation, one thing that we could do is that we could convert each of these to a z-score. So let's do that for the behavior problems variable. So we would ask the computer to compute all behavior problem scores to convert all of these, that is for each case, to a z-score. And then we would rerun the logistic regression. And with behavior problem scores expressed as z-scores, the EB is 0.246. Let's go ahead and interpret that. The interpretation is controlling for other predictors. As behavior problems increases by 1 standard deviation, the odds of a very positive impact decrease by 74.4%. And here's that calculation worked out. We subtract the coefficient from 1 to get 0.744, multiply by 100, 74.4% lower. And let's provide another interpretation of this EB of 0.246. That other interpretation is controlling for other predictors as behavior problems increases by 1 standard deviation, the odds of a very positive impact change by a factor of 0.246. 0.246 is very close to 1/4, so that for every 1 standard deviation increase in behavior problems, the odds of very positive impact are decreasing about 4 times. Now, foster parent is coded as a dummy variable. So where adoptive parents were prior foster parents, this variable is coded as 1. Where this is not the case, the code is 0. Because foster parent is dummy variable coded, we can interpret the EB coefficient, the exponentiated coefficient, as an odds ratio. So the exponentiated coefficient for foster parent is 1.257. Thus, controlling for other predictors, the odds of a very positive impact for foster parents are 1.257 times the odds for those who were not foster parents. Now we can make that interpretation because foster parent is a dummy, and to be more specific, we can make that interpretation because the values connected with these categories differ by 1 unit. We might want to interpret the coefficient for foster parent in terms of percentages. Thus, controlling for other predictors, odds of very positive impact for foster parents are 25.7% higher than the odds for those who were not foster parents. And how do we compute that 25.7%? Well, when the EB coefficient is greater than 1, to compute the percentage change in the odds, we need to subtract 1 from that coefficient. So doing so yields 0.257. We multiply times 100 to convert to a percentage. So the odds of very positive impact for foster parents are 25% higher than those for non-foster parents. Now, I mean, just as in multiple regression, predictors not in the equation are not controlled for. So predictors that we did not include could potentially be affecting, or we could say biasing, the coefficients for the predictors that are in the equation. One final point I don't know if I mentioned. Whenever the EB coefficient is greater than 1, that is conveying an increase in the odds as the predictor increases. So, for instance, the EB coefficient for education mom is less than 1. So this is conveying that controlling for other predictors as mom's education increases, odds of very positive impact go down. On the other hand, the EB coefficient for foster parent is greater than 1, and so this is conveying that the higher coded category, foster parent, as contrasted to the lower, the odds are higher of a very positive response for the higher category. So as the foster parent variable goes up, the odds of very positive response go up, and that's conveyed by the positive EB coefficient.